So a quick welcome back to everybody that took my advice a half an hour into the previous short unquote video. We are ready to start building the next set of things. In the previous video, which is 2 hours long, I ended up moving all of my belt work and pipe work up off of the lower floor. So I'm gonna call this the below deck. We've got all of our refineries down here, and they're in groups of 3 that came from that blueprint. And each group of 3 is bringing its input down from above and sending its output up. The water is attached to the underside of the deck, and the solids go up through the deck and are routed on this deck. I put in place a bit of frameworks here so I can, as I'm flying around, I can go up and down through that framework, and when I'm standing above it, I can look down inside to see things like, is my water actually working? Or I can look down and say, look at this guy here, and I say, oh, is he hooked up? He is hooked up and he is running, and I can see all of the front porch things. So the next step is the next set of refineries. And I've got that all staged up and ready to go. Basically, I have 9 refineries for Caterium, 3 for Quartz, and I've got one little area that I'm going to be using to do an aluminum scrap and solution pair, which I ought to build it by hand, but I'll probably build a blueprint of it and then place down the blueprint just for clarity, because it does do some, it does have to arrange the water in a VIP mode so that I use my recycled water before I use the inbound fresh water. Shouldn't be too much of a problem since the fresh water is coming in from up high. So yeah, that might actually be a fairly easy VIP to build. VIP is variable input priority. What it means is that if you have 2 pipes and one joins the other from the top, you by default take most of your flow from the one on the bottom, and if it isn't full, it will fill in from the top. We've used that in a number of places. For example, on our water tower, we have one pipe going all the way up and down, and then it uses VIP to fill in with the rest of them, so that they don't use the water with all the head lift. They prioritize taking from their water extractors first. And since the water extractors, 2 of them can fill a Mark II pipe, the amount of water being pulled from the water tower is a unit or 2 at a time, so he does just fine. Over here, it's going to be our aluminum loop where we get some fraction of the water comes back, and the bulk of the water will come from the fill-in above, but it still works. I have to decide whether I'm going to put a buffer on the recycled water and arrange a valve to prevent that from being filled by the fill-in water. And if I'm going to do that, that complicates the layout somewhat, because it means that we need to have the machine that's recycling the water and the buffer put together, and then that goes through a valve and becomes the lower part of what comes down from above. So that'll be complicated. But we can start off with the first one, which I've got showing on the screen, which is the pure Caterium ingots, which is just straight up Caterium ore and water turns into ingots. Turn that off. We start off with our normal copper ingot blueprint. Now I am going to go ahead and put this down not just for the Caterium, but for the next one. I'm not going to put it down for the last one because the layout for the aluminum, the bauxite processing into aluminum, into the aluminum solution, has to have these back to back. So one gets flipped around and I only have 2 refineries. So we've got that. Now these guys only have vertical connections to the one above them, which means I can go right to my upper deck and put it in place. And I'm clipping this onto the top of the lower deck items. I'm not clipping edge to edge. Clipping edge to edge works just as well. It can be a little fiddly, especially since I have these frames out here which are 1/2 meter high. So we got that in place. Now we want to connect up the power, and we want to connect our verticals, and we need to connect our water. And I will do the water last because the verticals are just damn easy, so we'll just slide those in first. This is the first set that I've done, starting with the blueprints. Power comes straight down. Where to go? There it is. I keep looking for the power and not finding it because it's buried right there. I'm going to get my altitude where I can see it neatly. There we go. So that's got power, the power downlink. Now I need to run the actual power, which is going to be out on the other side of these decks. So the next deck goes in. And I'm going to put in these walkways. These guys are just over where all of the water is. And I have to put the frame floors in manually. Not a problem. So the power is just one of these guys brought up to the point. And then I go underneath to put a nub on the bottom and connect it back so we've got our power lines just tucked right up underneath the grid. We don't need that power line. Now this guy heads back. No, he doesn't. He just heads right straight across. So now everybody has power. Now for the recipes next, I guess, these guys need to build pure quartz crystal on the end. I'm going to do all 5 of them, all 5 layouts. So we go here and we say, search for recipe, pure quartz crystal. So that's going to take 135 per minute raw quartz and 75 water and going to turn out quartz crystal. Let's double check my plan here. My plan says this needs to run at 181%, so 200 is right. So get all 3 of those set up. Now the rest of this, oh, wait a minute, we only needed 3 reps for Caterium. So these guys get quartz crystal. this is going to be, that's going to be where the aluminum is. I will leave the top deck in place, but the bottom deck can go away. So these are set to quartz. These get set to pure Caterium ingots. And we actually need to push this all the way up to 250%. The plan has them at 246.296%. So running flat out with 9 of them, we are just barely keeping ahead of what's downstream of us. So now we need to copy that into all the rest of these. So each group of 3 is going to be triple this, so 180 ore and 180 water and 90 ingots. And we triple that. Instead of 180, that's 480. Wait a minute. 60 times 9, so 540. So we have 540 ore, or 540 water, and half that on ingots. So we could do this with 1 drone port supplying us our Caterium and 1 pipeline supplying us our water. So what I want to do is get the water going first. So we will have all of our water in place before we actually start producing. And the way you do that is, first off, I lay the crosses in, so I want to put this cross exactly above it, which is from here, and to go to left 2, and that way 1, I think. And we're going to verify. I'm going to grab one of our indicator pipes. Yep, and there we go. So go find our power pole, we go to here, left 2 and up 1 like that. Let's just do them all. Thank you, autosave. So it still accepts input while it's frozen sometimes. But that time, I guess I didn't make any inputs. I guess I noticed the autosave in time. So we've got those. Doing the down pieces verifies we have things in the right place. So I tend to do those early, and I can't do it on this one yet because we haven't really specified. In fact, let's clean this out. I don't know what the aluminum build area is going to look like, so we shouldn't have anything going on there. Grab a pipe. It's easy to see if these are vertical by looking at them from a distance, so I'm going to place and then turn around and look at that. That looks good. That one over there looks good. That one looks good. That one looks good. Okay. So the first 3 are for the Caterium, which is going to need a pipe of its own. And the next one needs to come up and over here. I've done this before. If we step into our next line, it goes under here. This is where I realized that the frameworks were only half a meter tall. But that's okay. So we want to place our cross point, our intersection, somewhere just inside so it doesn't intersect with the smokestacks. It's this guy. We take this and we put it in here. And now this pipe is going to go down that way and pick up his input. And I want to use the indicator on these. He's not going to stop at the edge of his... Did I do that before? How did I set this up before? How often did I set up the verticals? So I need one vertical here, and then I need verticals every 4 until we can make the last run clean. So first off, here's the vertical for the main one. And this guy should be here. 1, 2, 3, 4. Question is, can I make one run from here? I think this is too long. Yes, it is. So we do another one. 1, 2, 3, 4. Now I think we can go 8, so we can't. We can go 7, not 8. So now we pick up our pipeline and we just run it right back like that. See, if I'm going to have to support, I want to support on the blueprint area boundaries. And there's going to be one more water line in there, which is going to go back for the aluminum. And I will just drop the supports for it right in place. Right on this midpoint here. That's enough clearance. I could cuddle the pipes up to each other, but I don't think that's really important. And having them separated a little bit gives us a little more space to think about what we're doing. I mean, these could have been right next to each other, but no real need. If we end up sending across 8 or 10 pipes or something, I will start making the pipes next to each other. Now, I don't know where this is going to go from here, but I know it's going to go at least 2 here. So let's pull it out. This is for the aluminum, which is going to be some fraction of a pipe. I believe that with 42 pipes, I may or may not need to split some things. So what I'm going to do is right now I'm going to look at my water requirements. We do have one of our pipelines which is only requiring half. And I forget whether it's... So this, okay, so limestone requires full, it's my rubber. So this line only needs to be a Mark 1. I'm going to peel that down to a Mark 1 just to emphasize what's going on here. So as I trace through this pipe, Mark 1 with indicator, come on. So we're actually using 240 out of this 300, which means that if one of these guys only needs less than half a pipe, I can make that one pipe share to 2 of them. Okay. So looking really quickly on my plan, I'm going to turn it back on. For the Caterium ingots, we need a full pipe. For the quartz crystal, we need about half a pipe. And for the aluminum scrap, we need a tiny bit. So I think the quartz and the aluminum might be small enough. So I'm going to add that up. That's 285 plus 72. Let's let's do this in game. So 285 and 72, and the whatever amount is needed for this guy. So 285 plus 72 plus 3 times 20. 20? Oh, that's the wrong one. It is in here. It's the rubber. He needs 80, so 240. So that's exactly one full pipe. I'm going to use one pipe. Now, I'm still bringing both of these out here, but I will merge them before we head, I will head down. I will merge them down at the bottom. Easy way to do that is to pull this down and drop it in place down here, just like that. So we want to merge these two and take from this pipe somewhere so I think what I'm going to do is bring it out kind of to the middle and do something not too unfancy. So we're going to have a cross there and a cross there. Now, if I have done this properly, okay, what I wanted to do is come out and then down toward me and then squiggle, but it's being a bit stubborn. So instead I will have to explicitly put in a lift. Like that. So we go from there to there, and then I take it from the right to the left so it jumps up at the end, and I can take these out and have the look that I want. And all of this needs to be no indicator, like that. That goes there. Now, which of these want to be indicators? Indicate the there and there. Yeah, I'll have an indicator there. This needs to fill up again, but once it's done, we're stable. Now we can take our Mark I pipe, and we're going to do something similar with this guy. But again, we're going to need to use our lifters. Just like that. So this one pipe should now be running, well, once I get everything working, it'll be running at 600, feeding my aluminum and my quartz, and down here through this Mark I pipe gets my rubber. I probably should have counted the number of pipes of water I needed while keeping in mind who was feeding what and how. Like I said, I've got 42 pipes coming up out of my thing here. I can expand that, but I think 42 was good enough. I like 42 for many, many reasons. Tip of the hat to Douglas Adams. but that gives me the 30 for the nuclear power and gives me another 12 to work with. I don't want to waste them, but I think 12 was kind of the minimum. Once everything is cranked up, I'll be able to look at the pipes and say, you know, how much is this pipe moving, and kind of move down the line and make sure everybody is mostly, you know, using over a half and all of that. And this last guy, well, he's going to chew up everything. So we're going to put in Mark II pipe, and we're going to come back down to here. And we're going to head over to here. And he's going to grab the next pipe from the right that hasn't been used, which is going to be this bottom line here. And I can just make a turn with him. And I do want an indicator on that guy. So he is now moving water. And it should start filling these guys up. They don't need a whole lot of water, but I like to have them full before we light things off. The other thing I'd like to do is actually let them run to saturation before I hook up their outputs. I know that's reverse of what I was saying before, but the outputs are here on the edge. They're really easy to see. They're not in conflict with anything. So I'm going to let these guys fill up. So when I hook them up, they'll be full. Oh, wait a minute. No, that doesn't make any sense. Yeah, because when I hook them up and they're full, then I have to drain them in order to get my performance. So let's not do that. I will go ahead and let them start draining as they start building. Again, I need to say, instead of I'm going to, I need to say I'm thinking about. So outputs are hooked up. Let's make sure that everything is all set underground. We've got inputs, power, water, output. So I think we are done below decks other than waiting for these pipelines to get some water. Because the way this works here, I believe it will by preference fill up the first guys and then start filling the second. And these pipes won't actually fill until the stuff below them is full. But at 600 cubic meters per minute, these are fast. Now this last one I didn't hook up yet. He needs to be no indicator. These are hooked up. And this guy isn't hooked up. This is because he's hanging free and ready to go out here where we're going to be making the alumina solution. Well, actually the alumina solution is the intermediate product. I think the output from that is the scrap, and he also has a silica byproduct. And that's going to be tricky because we're going to end up with inputs and outputs on both sides. So one of them is going to take the input from here and go out there, and the other one's going to take the input from there and go back here. I want the water on the left, which means the bauxite's going to go in from the right, I think. Well, we'll see as I start putting it together. But there'll be bauxite coming in from one side and something else, I think it's coal, coming in from the other. And we'll have a water loop on one side, and the other will be the alumina loop, which is just a pipe from one to the other. Sometimes I'll put a buffer on the alumina just to let it burst, because there isn't a whole lot of capacity in that. And often I will want to put a buffer on the water input. I've discussed this before. That means whichever refinery is producing the water to recycle needs to be coupled with the buffer. And then there needs to be a valve between it and the other half. The other half will be it coming in low, so the recycled water coming in low into the other refinery, and a drop vertically coming down providing water that is freshly pumped. What I may do is arrange those two refineries so that one's on the left and one's on the right, and we have all the space in the middle to do our buffers and our fancy piping to make sure that the valves are in the right place and so on. That will allow me maybe to have my downpipe right dead set in the middle. I'd like that because that keeps things clean and consistent. Now, with all that said, we need 3 lines of Caterium coming in. Here, here, and here, which means we need to put in a drone port over here in one of these 3. I can do it any of the 3. I'm willing to shuffle things back and forth. And what I'm seeing is we have a slot down here that we can use just fine. If I put my drone port here for my Caterium, I can put my drone port here for Quartz, and I will have to work out something for the alumina, probably the next 2 slots down on this lower deck. So let's do it. I need to open out this whole area just a little bit. Which means that some of my drone ports are going to lose power. I'm wondering if I should have just put dummy drone ports in, leaving them unpowered, but at least it would get me the geometry. Oh well, too late to go back and do that now. Okay, drone port. It's called drone port batteries other way. And while I am placing them, I will place the next 2 here. And okay, I'm still not really good at seeing whether it's in place or not and whether it's rotated or not, and I haven't been using the hologram stuff. So we'll try this again. Notice I have added a plate out underneath these guys, so we'll have to do that as well. Yeah, getting this to attach. Thank you, autosave. Getting these drone ports to attach properly is sometimes a little bit tricky, but from below it seems like it works just fine, and I can see that my belts are up there where I want them. Just like that. Now, these are a specific blueprint which I want to use. So all of these short footers can go away. Oh, didn't mean to do that. Let's try this again. So now I need to sneak in these blueprints, which are uncommon. So they are over, it's called a 1x12x16 concrete deck. And it snaps in pretty simply like that from below. And now we want to put back in the border strip, which also probably is going to be easier to snap in from below. Yep. So the new ports are in, and you can't tell which ones are new. Except, of course, that the new ones don't have power yet. So these guys are going to be providing some resources, which I'm going to have to lift through these panels and send down to the other end. So also these guys are just called Drone Port X. I think the first step is to arrange power. The easy way is probably just going to be to take this and stripe it across and then connect up the power. It's less fiddly if I do it this way. Yeah, that's bright enough. No, it's not. Okay, so power's all the way down. And now I can take this and move it up to that one. I believe that's already connected. Yes, it is. Okay, so that's got power. If I set these going, I should be able to program them up. So this is Caterium. Let's see, Caterium is DD2 something. Caterium is DD2F. Wants Caterium ore. We've got batteries, we've got power, and I can go to all ports, and I can say has Caterium. And we see DD2F. There are 6 stations for DD2F. They're all going to supply this one. And if I can't sustain the output, I'm pretty sure I can, but if I can't sustain the output, we will have to put a second station in for Caterium and merge their outputs. So these are all this port. But I am pretty sure that I can send all 6 of those guys. Now, if they're all sending drones that have a fractional load, it is possible that the drones won't get in and out fast enough. But I think even with a fractional load, they will dock, drop their load, and undock fast enough. What I want to see is I want to see drones that are sitting on the pad waiting to drain so that we have a full drone port. So that's going to be the Caterium ore, and it's going to come out some more around here, and I need to put it above the polymer resin and bring it all the way back to here where it can then supply those 3. Excuse me, this one, and this one. So the next step is bringing it up. Now, previously we have brought up our copper right next to it. So I am going to treat that as make this new one just like the old one. And I'm also going to bring it up. I don't want to clip through here, but if I bring it up here, I can dogleg to the right, make the final run into here, bring it back to the left, so we can zip around this guy without any problem. I don't want to add another little bit of height until I have to. And I'm going to run that now to see how I like it before I commit to having my actual before I commit to this positioning. Okay, so support, this the right place for the support. And again, just right here. And over here, we need a support and a turn. If I put this support in here, I can finish my turn here. Whoops, I went high. Don't establish the next height yet. The thing about not establishing the next height, that's a more matter of taste. There's absolutely nothing in the game that prevents it. And I could, well, if I move this over to 1, I might be clipping into there, but let's check it out. That might not be a bad idea. So we want to go from there. How does this look? I don't actually need to delete that support. I just want to look at this. So I don't like the way that clips. If it was just into the edge of the border, maybe, but that, yeah, that doesn't look good. So we're going to keep it the way it was. Which means over on this side, what I want to do is go from here. And I want to line it up with this guy. Oh, wait a minute. I need a splitter. So if the splitter is here, yeah, we want to line up with this guy. But I believe I can have the splitter itself give me the altitude I want. I need to sneak that into place. I need to put it here so I can get the 90-degree bend into that guy. Just like that. So that connection is like cha. And this connection, so it's either do it this way with the nice belt bends, or it's put other splitters in at the ends. I often do the splitters the other end. I'll try it this way this time, just see how it looks. And we need to go to here, up to altitude, and then over to that. Get rid of the support that we're not using. I'm wondering if I ought to make this look similar. I'm going to try it. If I move this out by kind of intuition here. Well, other than the fact that I bumped it up too high, that's not bad. So from here, looks good. So now my Caterium ore, which should be arriving, can now be placed on that belt. And here is the downpipe. So we want this to be at the same level as this guy. So it's 1, 2, 3, 4. And it's not a straight shot, but neither are these guys. I'm going to retrofit this one to have a similar look. Two, three, four. So along this line, if the belts are a little bit diagonal, that's not a problem. And this guy, same thing. One, two, three, four. So now we have Caterium ore, and we have a whole bunch of buzzards circling, and I think that's kind of interesting that we can have these guys just circling above waiting, but that represents materials that are available for us to drop off almost instantly. Caterium is flowing. It's getting split. We're getting some Caterium on each one. Let me check our outputs. I'm going to see what are we doing with the Caterium. Where does it go? So the pure Caterium ingots, they're used for quick wire, which is used for AI limiters. And quick wire and AI limiters are all part of the official Caterium outpost, which I'm taking my outposts that I had planned, which were like pump some water and do some ingots and do some construction. And I'm now saying, well, we'll put all of the refineries in one place and so on. But DD2 series stuff, that's actually water, Caterium ingots, quick wire, limiters, and control rods. And I think it requires output of quick wire and control rods to the nuclear power plant. And it's going to be sending a lot of quick wire. And the plan has, let's see, Caterium ingots are used for fused quick wire. And that's it. So all the Caterium ingots go the same place. They're going to go to 15 assemblers. And there's only going to be 266 Caterium ingots times 4. Wait a minute, that's times 4. We're going to have some really big assembler fields. Is it times 4? See, I've lost track. Some of my planning, I divided everything by 4, so I built it 4 times. These guys, 30 by 9, 270. So yeah, it looks like that's just an X1. So all these Caterium ingots from these 3 guys, I could send each one of them to a group of 5 assemblers, or I could take all of them and put them on one belt and take that one belt over, and at the other end split it out. I think at the other end I'm going to split it out because there's 15 of them. I haven't decided whether 15 is too many for a manifold or if I could just go for a split 1 by 3, given 3 sets of 5, and then the 5s manifold those. Haven't decided yet. That's a ways down. But that does tell me that I probably want to merge my Caterium all into one line. So the easy way to do that is to set up a really quick little merger. If I merge it pointing the output to the left, I don't know what's going to go on my left, so I'm going to merge it with the output pointing to the right. And I'm just going to do a real simple merger, because I will probably pull this up and do it differently later. And I want an ugly belt going into this guy. So remember to fix it later. And yeah, he's kind of out in the middle of everything, but there's his power. So that'll run and come to steady state while we're working on the next one. This will want quartz crystals, want to produce quartz crystals out of raw quartz, so we need raw quartz coming in here. So if we jog it to the left to get around that, then jog it back to the right, so it'll look like that one over there. Let's see if I can do that here. So I had one here, and one here, and then one in line with this guy. And I believe it was just here. No, it wasn't. It was here. And this guy, I think this was about here. Let's see how that looks. Yep, looks right. Except, of course, it's going the wrong direction. This is providing input, so it goes from here to here to here to this guy, which needs to be lifted. This is too high. And we have another autosave. Now here, I would like to drop a anchor point there, but I can't. So I'm going to have to actually manually sneak over to logistics and get myself a stackable conveyor pole and line it up. And that's going to be all the way across. And where did I put my quartz input? I think it was here. Yeah, I haven't assigned it yet. So it's going to actually come in over here. So he's going to have to come up and over and up here. So I will, so if I put it over like, how far do I have to put it over to get a nice 90-degree bend? That looks like about the right placement. Make sure this is going into the clip rather than clipping onto the other belt. You can actually place like this And it's tighter, but I don't like the way it looks. So that belt's coming up. I need to take this down and to the right and to that machine over there. So this guy. From here, I need to go down and over to him. If I bring it down on the right-hand side, well, then I have to go through the other belt. No, let's bring it down to ground level. So he wants to clip to here, so this guy's going to come down. And I need to stick it over 1, 2, H it. Floor is too steep. Oh, I know what to do here. I bring it to the right. That's just right on this line. Perfect. Instead of going up, I stop at the bottom. And there we go. So now we program this. So for raw quartz, nuclear power planning. This is DD2H. Go back to here, we could say find the ports marked DD2H. I don't remember there being that much raw quartz that I needed. Well, let's have them all delivered to me. So, yeah, raw quartz is supposed to be 366 raw quartz. It could very well be. I've got a couple of low yield ports out there, but I don't really need that many drone ports. Well, let's see how it works. Maximum transfer rate, 21 stacks per minute. And are we powered? We are powered. We don't have any batteries. Let's get some batteries going here. And let's get some batteries going on the rest of these. Almost forgot the batteries to the drone ports. That would have been bad because then I have to go out to the other stations on the other end and put batteries in place on them so they can battery up their drones and send their drones back to me. So in the future, I'm going to have to keep my eye on my throughput rates, knowing that I could be throttled if drone ports on the other end have no batteries at all and their drones are stuck. And alas, I cannot sort this by status. And alas, it shows the same status for the drone can't unload as it does for the drone can't move because it's got no batteries. So the only way I will know is if I don't have enough throughput, which means that if I've got a miner that's feeding 3 ports, and one of them doesn't have batteries, and the other 2 can keep up. I'll never know. So maybe long term what I do is I occasionally wander around with a full set of batteries and fill everybody up and make sure everybody has full batteries. Don't have to do it very often. Might only have to do it once. So we've got quartz coming in. And it's sliding in here. And there we have it. Quartz Crystal is making it 100%. Let's do our performance check here. 100%. 100%. Whoop. No copper ore coming in here. Well, that's because these aren't copper, these are Caterium. Why is this guy wanting copper ore? It should be pure Caterium ingots. Okay, so we have to check every one of these machines because I might be missing copying them from time to time. Caterium, pure Caterium. These guys are going to be pure quartz. There we go. And the next bit is the alumina. It should be easy enough. Let's plan it out on the... Oh, and we have sunlight. We have daylight again. Yay! So, what we want to do here is now build a... where to go? We want to build the bauxite refinery. So, bring you up in the other window. I'm going to keep that off screen for now because it doesn't mean anything much. So we need to take scrap silica. The heck? Well, bauxite outpost. I had the wrong outpost up. So we consume 144 bauxite plus water, giving alumina solution to the silica. And for now, we're going to dump the silica, but if silica will be merged with the silica coming from other things. That's what the rest of my raw quartz was for silica. Right. We'll get there. I will probably take my existing raw quartz line and put a splitter in it because I'm getting all of my quartz in one place. I think my total raw quartz in this build is still low enough. Let me check my grand summary. No, it doesn't show there. Silica. So there is a quartz outpost that produces both silica and pure quartz crystal. And the silica comes from a constructor, so it's not part of this build. The silica constructor will need 500 raw quartz. And the pure quartz crystal that I'm turning out requires 366. So we want to balance back and forth between the two. So when we put the other machine in, we will have to select which of the remote ports send to be used for silica and which send to be used for the pure quartz. Okay, that solves that. That's actually been bugging me. Anyway, if we can go back to thinking about the thing we're supposed to be building here, which is the alumina solution and aluminum scrap. I'm going to start by loading up the existing pure copper ingots. I want to get the placement roughly the same. So if I do that and I have the water on the right, Let's get rid of that. These do not trade solids between them. They will share liquid at both ends. I do want to keep this little pipeline layout here because that keeps me aligned with what's coming in up top. So we would have water coming down in here. Which means this guy needs to be flipped around. I think when I flip him around, these are going to swap places, so we have to get rid of the floor hole here. And here. So my best way of placing this properly, I think, is to leave one in place here. And I would turn this so that we are output facing this way. So this is the one that's outputting water. So we are doing aluminum scrap in this guy. So he will input the aluminum solution on the other side and the coal on the other side, and he'll output the scrap on this side and the water on this side. Which means this goes to here. This is going to be our water coming down. Now somewhere in here we need to tee off to go to a buffer. And then we need to have a valve. So the valve is going to look like that. Oh, you know, I think I'm going to have to move that over to the left because it's not going to work out very well. If I put my valve too close, I get no throughput. I've had that bug. Well, bug. System working as it's supposed to be. Misunderstanding. So if I put this about here and that about there, and over a little bit more. I'm trying to eyeball my pipeline length so that can actually join up. Just like that. Now I put this in this way. Hey, that works. So, the refinery, oh, this also needs to come in from the top, I think. Yeah, because if the refinery has output water, I want it to go somewhere. I want it to be preferred through the valve. So, we are going to turn this vertical. And I think to make things look good, I'm going to turn this one vertical. We already have to have a unique downpipe, so I might as well, just make it like that. And now we want to elevate our buffer. Now I've had things happen with buffers before. If I put it 4 high, it doesn't come in properly. So I'm going to try 3 high, see if I can make this give me a nice horizontal or vertical. There we go. That looks good. How do I feel about floating things? I feel surprisingly okay about them. Other people might not. I also feel okay with doing this. This also means I can do the same thing on the other side with the alumina solution, have another fluid buffer for alumina that's similarly elevated. So other side, so we have this guy. So his solid output, oh, that's the aluminum scrap, that's alumina solution. So he is producing silica out here, and he wants some input over here. Well, let's get our I need this to line up this way with him and with him. His input's coal. So we've got an input coming down way too close. Yeah, let's move these one out. I know, this makes it so it's not quite the same as the other ones, but I also have one up and one down. This is going to be a unique build no matter what I do. That's an input. That's an output, so I need to turn it. And now I've got my solution coming through there. I think having the liquids spread apart is better, as otherwise I'd have to jam all this stuff in between here and here. Okay, so I want to place this symmetric. Love symmetry, do that. Put this below and below, there we go. Which means I also need to have a crossing. Let's put it on the same line, so it's just right here. And yeah, so I do have to bring it out at least this far, otherwise it's gonna clip in there, which I don't like. Thank you, autosave. So if I made the autosaves delay longer between them, it would still be the same amount of time for each autosave, but that means if something went wrong, we would be going back a lot farther. And there's my buffer for alumina. And just for fun, I am going to color this white. And I'm going to color my recycled water dark blue. In fact, I'm going to color all of the water dark blue, because this entire thing carries recycled water. The fact that it gets topped up by fresh water going up is not a thing I worry about. That'll just be a normal pipe. So we have our two refineries. So let's see, what are my overclocks for this one? So the aluminum scrap is supposed to be running at 60%. I may overclock the whole thing a bit farther. If I do, however, I risk overloading something during startup. Let's just do it normally. And the luminous solution is also, I have 2 at 60% in my plan. I was going to build 3 of them and switch the middle one back. But if I'm going to be doing this thing with the buffer, I just need to have one of them at 120. And we can recover our, this one didn't, yeah, I put this one down fresh, so it didn't have any shards in it. So this guy, the same end as water, this is where output of aluminum scrap is, so I need to get that going. Now out on this end, I brought it out just a little bit farther. I'm going to do that here too. Just right there and right there. Give myself a little extra room. That's justifiable because we have a more complicated set of piping inside our thing here. So I now have 4 holes going up. That's an output. That's an input, and I put the holes too low. Interesting to see that it actually crimps it up like that. That gives you some ideas. I may be able to do vertical lifts that are shorter than normal. I have to experiment with that sometime. Don't need it here though, so I'm not going to mess with it. Wouldn't want to get this all built and have something not work because I was trying something experimental. That's an output. And that's an input. So our connections are 2 solids in, 2 solids out, and our water comes in. So let's see, I'm going to refer to my notes here. This will take 144 bauxite and 144 water and 72 coal, and it's going to produce 216 alumina scrap and a byproduct of 60 silica. And that 60 silica will merge with the rest of the silica we have, somehow assuring that our 60 doesn't back up. We'll have to continue to, once we have done that merger of our 60 plus the incoming, however we do that, we need to make sure that our 60 is always either used or sent to a sink. So that'll be up on the upper deck. We'll worry about that logic. So this is now a lower deck recipe for aluminum scrap. This is 260, 2 refineries making alumina solution and aluminum scrap with from bauxite and coal and water with silica byproduct. And that should have gone into our lower decks. Oh, I reorganized my blueprints while I was doing the other stuff. So you have aluminum scrap for lower deck. Let's see if it works. Needs to go under here. And the water needs to go to the left. So the water is the one with the more complicated piping. Okay. Start to do the hookups. Power. That didn't change place. Water is going to be different because this is coming off this way. So instead of placing an X, I'm just going to grab a pipeline and just take it straight up and over. So that is on the center line, and I need to send it just a little bit to the interior so that we don't have, well, actually I can do that. That actually looks pretty good. And I do want an indicator on that one. And the easy way is to find one and go, you, make you like him. And we do have water coming from over there. So I'm going to grab this. And I'm going to extend this pipeline out this way along his center line here until this meets up. Back it off by 2 and match. And this guy needs to be no indicator. So indicator here, no indicator in the middle. So the valve keeps us from simply pressurizing the fluid buffer from above. This guy should be full. This guy should be full. And now we need to run all of our solids up. They're all in different places from where they were before. So the easy way to do this is to simply grab this and sling it all the way up. And get rid of the old stuff. So there's our locations. Make the holes match up. And now we run the lifts properly. So this is an output. And this is an input. I'm going to face this to the left, so we're going to bring the input down the line and in. And this output's going to go into a sink. We need to fit 2 sinks in here. So I can fit 2 sinks side by side in this area. Just barely. I don't want them to ride up on each other. If I do an H. So there is no alignment where they really match. So I'm just going to have to separate them a little bit. That is, I believe, our coal input, or is it, it might be our bauxite input. but it's an input. It's going to come from the left. We can back this off a little bit. So that's too close for that. Can I make that line up? Yes, I can. And I can end it back this way. There we go. So this one, if I want to do it the same thing, floor is too steep because we have nothing to the right. I'll put this in long enough to get our sink in place. There, yeah. So we still have the problem, this is an input. Take it down the middle, take it down the middle. It's too bad my sinks are being pains in the asses. Surely there's a better way to do the sinking than this. Quantities are small, I could merge this stuff. Now these are both inputs. So where does this input come from? This comes from a coal, which I believe I have already placed the machinery for down below. Yep, I've got that one and that one, so I have our two inputs. So I wanted to bring it just to the right of this belt, which means I need to move this sink or clip it. Yeah, I can clip against it. If I didn't have this up, then this would just work. I can bring it over like that. Got to bring it up by one tick. Yeah, let's move that out of the way. I will figure out how to do the sinkage after I've got the other belts through. So I'm going to bring two belts up through here. You know, if I drop these guys down, I wouldn't have to do all this dog legging. Let's pause for a moment, and I'm going to go ahead and lower the iron ore into place. Is that too steep? That is not too steep. How about that? If I do that over here, that makes that a lot cleaner too. So if this is coming up this line, so it's here. Get rid of these. Tidy as you go is kind of important in most engineering disciplines. So from here, I want to go down I don't want to stop here, I want to stop here. But that floor is too steep. So for the moment, I need to replace this grid with a solid floor. So I can put this in place. I might have been able to put, yeah, I probably could have put the, the pole in place without any problem. Where else did I do? Here's where I did the other dog leg. So you are going to get pulled down as well. Let's try just putting the conveyor pole in place. And then this guy gets reworked. I'm going to go ahead and put conveyor poles in here. And he's going to be coming up the wrong line now. But I will maintain him at altitude until here. Actually, I put him here. I think this does a nice bend. No. Yeah, that's better. And I put it in the wrong place. Okay. That's actually much nicer. The other way to do it would be to bring it in here and have a splitter and then another splitter here. Don't fancy that. So where was I? I have my copper coming in. Got all these guys coming in. So we're working with this junk here. We've got these two outputs that need to meet up somewhere and get sunk. We have this input and this input, and I want to bring them in along this line. I am thinking that what I'm going to do is bring this out and around, although, what does this guy output? Silica. Yeah, great place for autosave there. Thinking. So I got two inputs, one in here, one here, and they need to run down this way. I've got space to put them. I can dive down here, down below, and depending on how I route the belts will determine which one is which. And if I route it from here down this way, he could be on the left, but if I bring it to the right of it, I can for now bring it to the right of him. I like that. Just like that, and we'll bring it all the way over so it will be naturally in place. And I can bring it all the way to this edge. I'll bring it to the middle here, then bring it up here, like that. Whoops, forgot to hook that input up. And what I'm hoping is I can bring this guy to here and over to here. I think that's, yes, that is just barely tight. There we go. And now these guys rattle onward over to here. Let's set up their poles first. Looking good so far. Okay, so I need to put the poles in. Anytime you're working around a merger or a splitter with open inputs or outputs, sometimes it will grab the belt you're working with, which is usually what you want to do. But in this case, it's not. So I put the poles in place first, and I'm able to drop it onto the poles. I'll run out to here. So both of these now need to go down. Easy enough. There and there. And they're actually coming from the port. And those need to hook up to the two ports that I added most recently. So this first one goes to him. So we're going to come down to the same level. 2, 3, 4. Let's get the same kind of diagonal that these had. And this one is going to come down and go this way. And I need to line this up with him. Perfect. So which one's which? The end of drone port is going to be this lane. Zoom, zoom into here. And this machine, the solid input is bauxite. So we need 144 bauxite per minute. So much nicer than the batteries where we had to have so much aluminum. So bauxite is DD2K. Come on. Wants bauxite. And he's got batteries already. Yay. And we go to all ports and we say DD2K. And we have two ports that have bauxite, which is just perfect. Because we probably could move 144 bauxite with one port. But having two ports means we've got drones that are ping-ponging, and I think it keeps things a little smoother. So if that's true, the other one, I believe, let's absolutely verify what the other one is. The other line comes all the way around here and around the back and into this guy, and his solid input is coal. And coal is DD2 what? DD2G. All ports. Has coal. So we are actually my plan shows 630 coal. What else does coal get used for? Let's see. We're producing coal. We're producing 630 coal per minute. We are importing coal, into our iron plant, right, for steel, which we haven't started on yet. And that's going to take the majority of our coal. It's going to take 558. And we're taking 72. So I'm thinking that we are going to grab just one of our coal stations, and that's going to be it. And the other 5 are all going to feed the other drone port. The other alternative is I can bring all of them in here, and then I can split off. Yeah, I think I'll do that. So I'll use a splitter to get the coal for the steel stuff. So all ports, DD2G has coal. Everybody's going to send coal here, and I will use appropriate splitters to take my coal line and divide it between this little bit that goes into what we're doing now and the vast majority of it, which will be doing steel. It'll be easy enough to find my coal line. And the other thing is now we need to put in an awesome sink. Yeah, I can slip it right between there. And I can put in a merger right here. And I'm going to leave the belt ugly. So we already have overflow silica coming up. We're not using any silica, so this is just whatever silica this guy is outputting. We need to sink until we have set up somebody to consume silica. And our other output is the real output, which will come out here only after we get coal. Notice we're getting a whole bunch of this all set up here. We have coal coming in. And we are not receiving our alumina solution, which means I messed up here somewhere. There we go. So the buffer will keep us pressurized, so we'll be able to burst consume and we'll be able to burst produce. The buffer should fluctuate up and down. This water buffer is merely a pressure relief. When we produce a burst of water, it will go into the fluid buffer if the consumer isn't ready for it yet, and then we will take from the fluid buffer, keep us topped up, and we will only take from here as needed, in theory. But 2/3 of our water is coming down this pipe. Total water consumption is 216 per minute, so 2/3 is going to be quite a lot. The important thing is that our water here should always swiftly drain. As long as that's happening, we're good. Independent of anything else that happens in that water feedback circuit, as long as we are not preventing this from making progress, we're good. Also, if we don't use his water, then I believe that the 600 rated line we've got coming in, we may overbook it if we're not using our recycled water properly. But we are now seeing significant aluminum scrap come out of this machine. 216 per minute and on a 780 belt. Yeah, okay, that'll do. Hey, we got 9 more coupons. Remember, we've got these huge point spikes coming in as our other nuclear reactor turns out plutonium fuel rods, which get synced. If you burn the rods, you have to do something with the waste. If you just make the rods, you can sink the rods. You can't make you can't sink the uranium waste, but you can turn it into plutonium rods, which you can then sink. So I have that 90 gigawatt reactor out there on the other side of the world, which is running without actually accumulating any waste in storage anywhere. Yay! So we have 3 normal uranium nodes and 1 impure. The 90 gigawatt reactor is draining the impure nodes, so it's taking 1/7 of all the uranium on the entire build area and turning it into power without accumulating waste. We're going to be doing a normal node over here, so it's 2/7 for 180. We can do 2 more complexes this size for nuclear power if we need to. I doubt we need to. I think it would dominate my whole world just to produce the power, and I wouldn't have enough resources left to do anything useful with it, but kind of cool to think about. If we need more power and I'm willing to set aside a corner of the world to grow heavily radioactive, I can put up a little concrete bunker and fill it with industrial containers and start stacking that stuff up. And we can look at how long it takes to fill a container from whatever plutonium reactions I do. I'm deferring that because I think 180 gigawatts is going to be enough for the build that I want to make for the final complete objective phase 4, which we see in the upper right, which I haven't even started yet. There are things on that list I've not even looked at the recipes for yet, other than tossing it into my planner. But with that, all that's left is waiting around to make sure that these guys are running at capacity. And things are slow enough that actually we are seeing 100% across the board already. I believe I already checked these. Yeah, because one of them wasn't even Caterium. So performance check looks good, and we have buttoned things up nicely. Let's see here. I want to put another set of foundations out here before we finish. This is deck with frame. There we go. So we've got our nice squared off area that we have built. I can clear the designer and remove it. And I believe that is all of the refineries that are needed for the nuclear power plant. And every one of those awesome sinks is an output from this particular area. Can't really call this an outpost. Maybe it's an inpost. But this is the refinery cluster. It looks like I only have a couple of... Yeah, I've only got the one blueprint hanging off the end of here. Otherwise, it'd be nice and square. Oh, well, there's nothing to be done about that. I mean, we can't do without that product. I mean, that's our... Yeah, we have to have all of our iron coming through. Hold on, wait a minute. Why does my iron ore... That, the lighting made that look like bauxite, I swear. Is it near sunset? Yeah, okay, so the light is starting to shift for the evening inside of Satisfactory. I am happy with where this factory has gotten today. So I will sit back and think about my next steps. Think about whether I want to do constructors and then assemblers, or if there's some better way to arrange things. I still have a lot of space out here. I like the idea of doubling up and having the upper deck and the lower deck. So the lower deck for the machines, and the upper deck for belts. And from here, we won't need to worry about liquids until we start working with the blenders and the final stuff. So it's going to be upper deck is for belts and for sinks, and the lower deck is for machines. Do everything with lifters, do all our power vertically. I like the organization. And with all of the greatest affection, I am still looking at all of these things circling, and I still look at them and think of vultures. So these are my nice friendly vultures. And with that, I will cut the recording, and when I come back, we'll be onward to the next major chunk of the 180 gigawatt nuclear power plant.